Hello, my statisticians. This is Professor Sampson from PS I Love Math, and I'm here again with another statistical banger. You know, I love that word. I love math being a banger. I just love math, love math, love math. So, anyway, in our series, because today I'm dropping 4 videos, banger after banger after banger after banger. So, today we're continuing our hypothesis testing with 2 samples. And this video is going to focus on 2 population means when the standard deviation of the population is unknown, and these are dependent samples. So last time we were doing, in the last 2 videos, which you can see at the end of the video somewhere over here, if you want to check those out. But this time we're doing dependent samples as opposed to independent samples. So let's get ready to get right into it. Oh, it's dark in here. It's 3:30. It shouldn't be dark. I guess it's about to storm, but you don't care about that. But real quick, don't forget to like, comment, and subscribe. Subscribe. You know I'm dying for subscribers. I'm not dying for viewers because people want to see me, you know. So subscribe to my channel. So enough of begging for subscribers as I usually do. Let's jump right into this video, and I got a mathematical problem to share for you right now. Wow. So let's get started. The manufacturers of a new eye cream claims that the cream reduces the appearance of fine lines and wrinkles after just 14 days of application. To test the claim, 10 women are randomly selected to participate in the study. The number of fine lines and wrinkles that are visible around each participant's eye is recorded before and after the 14-day treatment. The following table displays the results. Test the claim at the 0.01 level. See, this is something for me because I just look good, but I'm about to be 50, so you know a sister need to see about those wrinkles that might be coming up. Okay, let's go back to the screen share. I'm doing too much. Okay, so let's see about this. Now, what kind of, remember, all your problems are gonna be mixed up. They're not gonna be in sections and little videos and little sides when you get your exam. So how do you determine? Well, you determine that these are not 2 independent samples. These are the same 10 women doing a before and after. So one of the things that we do have to discuss, when I usually don't discuss information like this, because I usually leave the teaching up to your instructor if that's what you want to do, but I do have to mention this because we are talking about a dependent sample. So in a dependent sample, we are talking about pair differences. So we are actually comparing the differences. So the difference formula is actually D is equal to, let's say, Y minus X. And as you know, mathematically, it's important to determine who's Y and who's X, right? Because 5 minus 8, my difference is going to be what? -3. And 8 minus 3, my difference is going to be, 5, my difference is going to be 3. So we need to have a way that all of us decide how we're going to determine what's Y and what's X. So for this particular video, and for many of your instructors, just double check. We're going to say that the after is going to be our Y, like we normally would do in a regular chart, right? And our before is going to be our X, right? So take that into consideration, that if our before, right, is expected to be lower, all right, you're going to have more what kind? You're going to have more negative numbers. And then if our X is expected to be higher, you're going to have, rewind. If our X is expected to be higher, then you're going to have, you know, negative numbers, and vice versa. So just keep that in mind so that you don't think it's not possible to have negative numbers or whatever. But anyway, I had to throw that in there because if I didn't, we would be confused and you would be confused at what answer. So this is how it works. So this is what we're going to go with as we focus through this problem, okay? So we have our before and after. So the thing that we need now is our mean difference. Now you could go working through hand in hand trying to figure this out, you know, in mathematically, but I'm going to show you, by hand, but I'm going to show you how to put these numbers into your calculator. So if you want to follow along with me, you might need to pause the video so that you can go and put these numbers in. So we're going to put the X's in X1 in the first line, and then we're going to put the Y's in the second line. So let's do that now. Let's find my calculator, and we're going to get started on those numbers. Okay, so what I did was I went ahead and put all those numbers in from our example here. So remember, you can always go back and pick those up, but I didn't want to make the video longer by you watching me put in the numbers into L1 and L2, which you should be able to do. But I'll show you where it is just in case you don't. You go over to stat and you just hit edit and you hit enter, right? And then you put your numbers in L1 and L2. I didn't do the next step because I thought it was important that you saw the next step. So L1, I got my numbers in and hopefully they're fine. Please always recheck your numbers and go through and make sure that they're correct, because remember, garbage in, garbage out. If you put garbage in, your answer is already wrong before you even start any work. So double check your numbers. Your instructor cannot see your calculator, okay? And the only thing we can say is you must have put something in the calculator wrong, all right? So anyway, I'm assuming that I put these right. So now you need to go over to L3, all right? And what you do is you hit the up button to get right on top of L3. And we're looking for the mean differences. As we talked about earlier, the mean difference is going to be y minus x. And for our purposes, we assume that y is L2 and x is L1. So what you're going to do is you're going to hit second number 2 for L2. Then you're going to hit minus. And then second number 1 for L1. So that you can get those differences. So now you see the calculator populates the differences between L2 and L1. So in this case, unlike the other ones where you were working with two independent samples, you were working with L1 and L2. In this case, you're only working with L3 because that's your mean differences, okay? So we'll talk about that a little bit more in a minute. So let's get back to our original thing. The first thing we want to do is our null and our alternate. We're still working with those. This is a hypothesis test, and we're testing something, so we need a null and an alternate. And we're talking about a mean again. So this is going to be mu sub d, because you're talking about the difference between the two. And that's going to be equal to 0. What does that mean? Mu sub d equal to 0. That means that there's no difference. There's no difference between the two. You had 8 wrinkles before, you got 8 wrinkles after. You just wasted money on some cream. That's all it is. So you always start off with there is no difference between this stuff, okay? That's your null hypothesis, always equal to, all right? So then your alternate, what is your alternate going to be? What do you want to have happen to this difference here, right? Do you want it to go up? Well, no, you want the difference to be what? Lower than 0. So if you're at 0, do you want to have this cream and then after this cream you have more wrinkles? No. The purpose of the cream to spend your money so that you have less wrinkles. So that's going to be less than 0. Okay, everybody follow that? Stop and rewind it if you need to. Okay, so mu sub d is going to be less than 0. All right, so you have your null, you have your alternate. Let's talk about what we're going to be doing here. All right, well, we don't have population anything, okay, because we're working with these two samples. So we don't have population anything, so we don't have to worry about that. So we're going to be using our paired difference formula. So I can pop it up here and show it, and then I'll write it down. You know, I have my formulas here on my little formula card here. And we're going to talk about paired differences. So let's see if we have it here. Right? So difference between two means match pairs, whatever you want to call it, match pairs. And here's the formula. It actually looks like what? The Z formula, x bar minus mu over the standard deviation divided by the square root of n. See, think about it. So even though we give you formula sheets, I wasn't given a formula sheet when I got my bachelor's in math, but the formulas are easy to memorize because they're all the same. They just change the letters, okay? So let's put our formula here for our test statistic. So we're going to have T, because we don't have population standard deviation, all right? That is unknown. D bar, that's the difference, all right? Minus mu sub D, which we are not going to know, because of course, all over the standard deviation of that D divided by n, square root of n, okay? And what you need to do here is plug in these numbers. Now, what I ask my students to do is to write these numbers down properly rounded to the right decimal. So I don't know about your instructor, but the proper rounding for this is that these are all whole numbers. So for the mean, you have to go one more. For the mean and the standard deviation, you have to go one more than is listed in the data. Okay? So that's going to be D bar. So I'll show you how I quickly get D bar in the standard deviation. You can get it other ways, but I like to do it in twos. So let's go back. I like to go to stat and then over to calculate. I don't even do my test yet, and just go quickly to one variable statistics. You should know about that. And then I'm going to select what? L3, because that's where my differences are. Second L3. Nothing in frequency list, of course. If you don't know, check out another video. But anyway, so here we have it. Okay, we have our X bar is -1, and you need to put -1.0. That's our D bar. And then we have our standard deviation of the sample here, which is 0.9. Okay, and so that's what I'm going to ask my students to make sure that they write down when they write down the formula on a piece of paper. The test we're going to definitely be doing in the calculator, but you have to write down the appropriate numbers in my class to get the right answer. So D bar is going to be what? Is going to be -1. And so you might want to list them over here, -1.0, because you have to have one decimal place. And the standard deviations of D, all right, was equal to 1. I think I said 0.9. That's why I like to write them down so I don't have to go back to my calculator, 0.9, because that's one decimal place more. All right. So for my students, they have to plug in these. Again, it may be different for your instructor. You might have to ask him or her, you know, what's going on. Okay. So in this case, we're going to have what? Do we know mu sub D? No, we don't know mu sub D. All right. So we're going to have -0. That's going to be -0, just so we know, all over the standard deviation, which is 0.9 divided by the square root of n. And we had 10 women there is equal to. Now you can go to your calculator and do the test. Now that I see that you know all the proper numbers. Now let's go to our calculator and do the test. So what kind of test is this? All right, what kind of test is this? Stat test. All right, what kind of test is it? Is it a 2 sample because we have 2 samples? No, it is not a 2 sample, all right, because we only have 1 sample. We're only dealing with the difference, which is 1 sample in 1 line. So is it a Z test or a T test? Well, do we have the population standard deviation or don't we? We do not have the population standard deviation, so it is a T test. Yay! Hopefully you got that. It's a T test. So that's number 2, hit the T test. Now, do we have stats or do we have data? We actually do have stats because we wrote them down, but we have data. So we're going to go over and hit the data button. All right. We're going to go over and hit the data button. All right. Once we hit the data, we're going to leave mu sub naught as 0, of course, and then we're going to go and find out what list we're in. Well, we know we're in list 3. That's where our stuff is. Leave everything alone. Don't bother it. But here you want to check and make sure what you had. And ours was less than 0, right? And remember, they have mu's. We're going to have d's, okay? So it's going to be less than 0. Right, so make sure you check that. And then we go down and calculate. Right. And you see the X bar and the standard deviation also come up here, but that's just not where I go. Remember, this is a T test, and T has 3 decimal places because the chart we're going to use has 3 decimal places. Okay, so let's write this down. So it looks like -3.354, right? -3.354. So make sure you write that down. Let me go back. So your T test is going to be negative 3.354. Round it properly. Okay. And we're going to go ahead and do the same thing. We're going to do our critical value method, assuming maybe your instructor will let you choose methods. All right. If they don't, you know how to do both. So the critical value method, our critical value, we're looking for less than, so I'm going to put it less than here. We're looking for stuff to the left. That's going to be our rejection region. All right, so T critical value. What was our alpha right up here at the 0.01? So alpha was equal to 0.01. All right, now you know for a t-test we need degrees of freedom. So our degrees of freedom equals 9. So 9 at 0.01. Let's check out that t-chart. See, we're getting faster at it online, so we should be extremely fast at it there. So equal to 9. So 9 is here. So we want 0.01 right there. All right. Looks like 2.821. All right, 2.821. So your T critical value is 2.821. Is it? No, it's to the left. Remember, that chart only gives you to the right, and we're assuming that it's normal distribution, 2.821. So it's negative 2.821. So your critical value is negative 2.821. All right, and where's your test statistic? All right, where's your test statistic? Well, your test statistic, negative 3.54, right? 354, whatever it is, right? Anyway, it's over here. So it's in the rejection region, right? So what are we going to do? So the next step is to write, we're going to reject that hoe, as usual, right? Reject that hoe, right? Using the p-value method, and then, using the critical value method. And of course, if we use the p-value method, I'm not going to go through the p-value range. Remember, with a t method, p-value, versus alpha. Remember, you can't find a p-value on a t-chart, all right? You need statistical information to find an exact p-value, or else you'll be using the range, and I showed the range on the last video. But just to find an exact p-value, not to make this longer, the p-value is 0.0042. Remember, you have to have 3 decimal. I didn't do significant figures for my class. 0.0042, and that's going to be in reference to what? 0.0100. So 42 is definitely less than 100. And again, we're going to reject that hoe. All right, reject her, put her out. All right, so reject the null hypothesis. So reject the null hypothesis. So I'm about to get me some skin cream up in here. All right. Why? Because what is our conclusion, right? The conclusion. Like the final conclusion. Oh, what's that show? Final conclusion. On cheetahs, right? And the final conclusion is, all right, so that's what we're doing. All right, our final conclusion is what? Let's get it typed up all up in here. All right, now let's talk about this cream. So we go back to the people and we look in their eyes, and we look in Professor Sampson's eyes, and we say what? That there is sufficient evidence, right, to support the claim. That what was the claim at the time? What they have at the claim at the time? That the new eye cream, right? And the claim is up here, if you don't remember, right? To test the claim, 10 windows, right? That the new eye cream claims that the cream reduces. Let's talk about it. Let's talk about it up in here. Trying to talk about something. Jacking it up. All right, what happened? that the new eye cream, what it does, I don't forgot what the new eye cream is. I got reduces the number of visible fine lines, right? Reduces the number of visible fine lines, not fun lines, fine lines, right? And wrinkles, and wrinkles. That's what I'm talking about. Around a woman's eyes. I ain't put the apostrophe in, but you get the point. I know it's supposed to go there. After 14 days of application. That's what I'm talking about. Booyah! Hit the enter button. Maybe not. All right. So that's what's going on up in these parts here. Let's get it together. All right. So your conclusion is there is sufficient evidence because you rejected the null hypothesis. You rejected the null hypothesis that there was no difference. And you actually supported the null hypothesis based on your test that there is a difference, that if a sister takes this 14-day cream, that these bags are going to go away, you know, at 50. So you have enough evidence that after 14 days that this is going to happen. So as you see everyday statistics, so I take off my specs here. You can look up there. See, you see any? You see? You see any wrinkles? I hope not. I have on no makeup, right? So that's what I'm talking about. So that's when you see Revlon and Neutrogena and all those places that do these eye creams, they can make these claims because they've got statisticians to do their tests to determine whether or not these things work or not. Did they come to a statistical thing at some particular level? This is a 0.01 level. So this includes other levels. So you want to get close as possible. 0.01 is what, 1%, 99%. So that's pretty good, okay? So you want to make sure, man, maybe it didn't come out right at, you know, less than that or whatever. But anyway, we pretty much sure that these wrinkles that's not here yet, even going on 51. All right. So anyway, we sure that the wrinkles ain't going to be there. So that is an example of that statistical information. So I hope you have fun. I had a blast doing this problem. And see me for another one because I'm dropping 1, 2, 3, 4 bangers in a row today. But thank you so much. And this is PS from PS I Love Math. And you know I love math. See you in the next video, which is over there. And don't forget to subscribe.